Hi, hello everybody. So we warmly welcome you to the Colombo White Hat Security Meetup. So sorry for those who are back. I think everybody is comfortable with the seating and all. So actually we didn't expect all those who expected, all those who RSVP'd to the event would come, but it's good like you guys are interested in the event and all, so it's glad to see such a crowd. So I won't take much time. So I'll quickly go through what you can expect from the meetup, how you can contribute, what's the vision and all. So this is the motivation, so we want to create a platform, provide you a venue for you to come and share your experience. We know a lot of you are working on security related research projects in your organization, in your universities and all. So we want to bring you all into a place where we can have networking, where we can discuss and share the knowledge, experiences, and drive the cybersecurity arena of Sri Lanka, right? So these are the focus areas that you can expect not only in this meetup, like in the upcoming sessions. So the first one is wireless attacks, threats and prevention. So that's what we are going to focus on today's meetup. And so interesting topics will come in upcoming sessions like API security patterns and practices. When you are developing APIs, how you can secure them, what are the best practices, like when you're using protocols like OAuth and all. You guys can hear, right, the band? Okay. So pen testing with some tools. So penetration testing is also important in the security domain. So how you can do that. And Docker security, that is like most of the organizations are moving forward with Docker-based development, like container-based deployments, even in production environments. So how we can integrate security with Docker, so we will talk in future sessions. Mobile app security and pen testing, so how to test the security of the mobile applications. Okay. So IoT security, a lot of students are there doing IoT related projects these days, and also we at WSU had a session for the IoT server that we released recently. Okay, malware analysis, so and security with usability. Let's say now you may be trying hard to secure your system. Let's say you are developing a website, so you enforce the password policy to be 20 characters long with all the validations like capital letters, simple letters, but if the length is 20 characters long, so obviously it's difficult to break, but the usability is not there. So how we can apply the best practices of usability and improve security. And security and quality assurance, so in the QA process, what should be the practice for testing security. And OWASP top 10, so you already know. And SDLC, how you can follow the best practices. Okay. So these are the action plans. So we want to create a forum where you can ask questions, where we can provide our expertise and all. So bi-monthly meetups. So that's it's a bit difficult. We are working, and so we want to bring you all in here. So initially our plan is to have meetups every 2 months. So but with your feedback and all, we'll try to maybe even go ahead with monthly meetups as well. Yeah, so bringing in security experts so initially today's session will be done by Ayoma, working in WSO2, but this is not driven by WSO2, so we are some individuals. So you also can become a part of us. So outsiders can come and contribute, you can speak even in future sessions. Yes, so there are lots of available opportunities there, especially for students or people who are working in the industry to go abroad and follow PhD or something like that. We get to know about such opportunities, we can let you know about those stuff. Okay. Yes, how you can contribute. So first thing is attending the meetups like you already did. And we hope you would come in future as well and become a speaker. If you're working on a research project, or if your organization is developing some stuff that's related to security, you can share the experiences with the community. Okay, so you can talk to us, reach us, and let us know what you're doing. So we'll arrange a meetup for you to share your experiences. And providing sponsorship, like there can be like, one thing is there can be like people from media, so you can provide us advertising and all. So and many more. Let's say you may be coming from some certifications providing organization and all, so you can offer free scholarships or something for the people who come in and the students. And spread the word. So you can tell your friends that you attended this session, you got something, you learned something, so they also will be motivated to join us in future. Yes, special thanks to WSO2, so providing us the venue, the mics, the setup, the video recording, and everything, the refreshments and all. So we really appreciate that. And Hackers CG, they're the people who are like doing the advertising and all. So we didn't ask them, they shouted at us and reached us and helped us spreading the word with everybody, so you got to know about the meetup and all. So even the events that we share, the images, logos and all, not the logo, I mean the other banners and all, so they helped us preparing them. Yes, so that's all about the introduction. So let's move into the session today. So let me introduce Ayoma. So he's a colleague of me working at WS2 in the platform security team. So he's like having lots of expertise and experience in security. So if you came for the Java meetup 2-3 months back, he did a session on browser security headers, especially for Java. So now today we'll be talking about wireless security. So without further delaying the event, so I invite Ayoma to continue this session. Thank you.
Thank you, Tharindu. So it's good to see you all here. So it's a new experience. So we have a security meetup that we can talk about security itself. So here the first presentation is Pentesting wireless networks and wireless network security. So let's move ahead, and I'm not going to go into presenter mode much because I will be shifting between demonstration and these slides. So if I introduce myself a little, I am Wijethunga, and this is tagged out from my blog, which pretty much explains myself. And thank you, Tharindu, for the explanation, for the introduction. So I am pretty much interested in Arduino, DIY projects, IoT, Java, software security, and of course WSO2. So you can contact me over any of these contact channels, and of course I'll share same towards the end of the session. So about today's agenda, so we'll be talking about hidden SSIDs, but it's not really security, but there are some people who use hidden SSIDs as security. So we'll be talking about hidden SSIDs, then we'll talk about WEP and WEP related attacks, then we'll talk about WPA, WPA2, sorry about the mistake, and then we'll be moving ahead with WPS attacks. And all these sections will include a short demonstration about how to use various tools in doing these attacks, and how a pen tester can really pen test these kind of networks. So towards the end of towards the second part of the session, we'll talk about how to secure a personal WLAN, and then we'll talk about how to secure enterprise LAN. And of course, another interesting thing is we got so many open free Wi-Fi networks now. So we'll be talking about why you should really try to avoid these open networks, and what's the real reason behind it. So finally, we look at the future of future developments related to these Wi-Fi hacking and wireless network areas. So towards the end, we'll talk about what more to expect. So wireless networks, or when it comes to wireless networking, it's not just limited to Wi-Fi, or it's not really limited to that. So in terms of wireless networks, there are many other things like Bluetooth, like RF. So we'll look at what are the things that you can expect from WhiteHat in future. Okay, so before moving ahead, so if you have any questions, you can raise me during the presentation itself, so then I can cover any of the questions then and there. Okay, so hidden networks, are they really secure? So what's the methodology behind hidden networks? So in normal network, a Wi-Fi router would advertise what is its network name, what is the current strength of its signal level, and all those kind of details in a beacon frame. So in a regular router, let's say a router that broadcasts SSID, a router that has SSID broadcasting enabled, it will send these beacon frames frequently to let other devices know that this Wi-Fi wireless access point is available. So this beacon frame includes timestamp, interval, SSID, capabilities, and parameter set, of course. So now in terms of hidden SSID, this would change, and the router will not really broadcast these beacon frames. Instead, a computer that has connected with the hidden access point previously will broadcast something called a probe request. So a probe request will let access points around the machine that a computer is trying to connect to WhiteHat Wi-Fi. So in our example, our Wi-Fi network was WhiteHat Wi-Fi. So whenever someone tries to access this network, whenever a machine comes near an access point with this name, a probe request will be received by the router. And as you can see, the router's real SSID is still exposed. So in a normal scenario, it was sent by the router, but in a clocked scenario, it was sent by the computer. So anyone listening in the middle towards the packets that are sent in the air, they will know the SSID. So it's pretty easy, and all the tools that are around can pretty much detect these hidden network IDs. So it's kind of like this, we're trying to hide. But okay, so as I said, even the slightest thing will include a little demo. So let's go through this demo, but this demonstration is purely focused on introducing the tools that we are going to use rather than talking about hidden networks, because it's pretty much not secure anyway. So okay, so I'll be using Kali Linux throughout the session. And before starting any of this, let me introduce the network devices that I'll be using. So there are two modes that a network adapter can act in a network. So normally they are in managed mode. Let me just really zoom this up. So if I run iwconfig command, you can see current interfaces that are available in this machine. So I have WLAN 0, which is in managed mode. So managed mode means this device, this tiny device, will only listen to packets that has its MAC address as the destination. So any packet that arrives from someone else will not be captured by this device. So there are some special chipsets that allow enabling a mode called monitor mode, in which you can listen to all the packets broadcast around you. So there are special devices that can, special chipsets that can enable this feature, and there are special devices that has these chips within. So this is one guy, it's TP-Link WN722N. So this is pretty much available in Sri Lanka. You can find it in tech shops. And I have two more devices. This one is not branded, but it's pretty cheap. You can find it in eBay. Sorry, I can't tell the name or something because it's pretty much unbranded. So you can find these kind of devices, and this is kind of the king of these monitor mode things, which is alpha. So if you have an alpha card, you can run audits for long period, because this is pretty good in handling temperature and all that. So if you are starting, you can use some devices like this, and if you want to run perform long running tests, you can use an alpha. So let me just show you how we can enable this monitor mode. So I'll be using AirCrackNG tool suite throughout the presentation, but there are other tools. Since AirCrack is pretty much common and it's pretty much easy to use, I'll be using AirCrackNG. So if okay, so there's a tool called AirMonNG, which can enable monitor mode on various devices, supported devices. So I can say sudo AirMonNG start WLAN 0. So it's going to detect my chipset, it says Athros. So it's going to change that into monitor mode. So now if I do an IW config, you will see that it's in monitor mode. So basically it can read anything, any Wi-Fi, wireless packet that is running around here. So now since we are looking into hidden networks, let's just run another command, which is arrow dump ng. So you don't have to really remember parameters and all that, it's all there. So you can run this, and instead of WLAN 0, we can say WLAN 0 mon, which is our monitor interface now. So as you can see, we see a lot of networks that are running around here. So we have a bunch of networks from WSO2, and we have some hidden networks like this. So we have our test networks, which we'll be using in next slide. So we see one interesting guy. I'm going to stop this. So as you can see, there is an open network with hidden SSID. So if any user knows what is the SSID of this device, he or she can simply connect to it and do whatever they need. So instead of listening to all the traffic flowing, I am going to listen to this particular BSSID, which is in channel A. Yes. So here I am listening to all the traffic flowing between traffic that is going on with this BSSID, and whenever some device will try to connect to this machine, or whenever some device broadcasts a probe request for this access point, we will get the ESSID, or which is the SSID for this. So let's try connecting to this device from another machine. I'll give a minute. Okay, sorry about this. I need to get help from Tharindu as well to connect it to these networks because my other machine went off because of some reason. So, okay, so Tharindu just connected to my network and it's simply WhiteHat hidden. And now I can read the packets that are flowing between Tharindu and the access point. At this point we are going to stop there. So this is an open network, so any of you can connect with this network simply giving this name. Don't connect because we are going to talk about this in a while. So cool. Okay, so we pretty much covered Ayoma NG, which is for enabling so we pretty much covered enabling monitor mode using Ayoma NG, then scanning all networks with arrow dump, and then we scan a particular network in a particular channel using arrow dump NG then again. And since Tharindu simply connected to the network for the first time, we could get the network name then and there, but there are situations in which you can't really get the, oh, I see someone is connected. So you got free internet. Cool. One more thing, and if Tharindu is already connected, I won't be able to simply see get a probe request because he is already connected. So in that kind of a scenario, let's run this again. So in that kind of a scenario, what we can do is we can de-authenticate Tharindu and make him reconnect to the network. So for now, don't connect to this network. So I'm going to run AR replay. So then again, you don't have to remember all this command because AR replay has some command that you will need to remember. Let's say if you want to do a fragmentation attack, you can remember this -5. Most of people do that, and most of people block with this -5 and all these things. But you can simply type the name. It's easier to remember. So let's say deauth, and I am going to give the access point MAC address, which is this, and I am going to give the client MAC address. Let's say this is Tharindu. And finally we are going to say W101, and we are going to define the number of deauthentication packets we want to send. So let's say 2 for now, and if we run the monitor mode again and run this, it's going to deauthenticate Tharindu so that he will send a probe request again. So let's say you have a network that doesn't have much activity but only one machine connected to it, still you can deauthenticate someone and simply get the SSID, so it's not secure. Okay, so this hidden network ID, network as hidden SSID concept even introduce additional attacks. So this is an example which used to work, which is karma attack. So in karma attack, you can simply set up an access point which sends crafted probe responses. So let's say your computer is looking for a network called WhiteHat Wi-Fi. When you send the probe request, the genuine access SSID will say I'm here, and you can say I am here and I am near, and it will connect to you. So this will work in open networks. So you can simply spoof access point and get the client to connect through you and do a man in the middle or using any other attacks. So simply saying don't keep the networks open. So next interesting part is web. So in web we have two types. Let's see, kind of type. So you have a 64-bit key based web and 128-bit key based web. There are some vendors that introduced 256-bit keys and all that, but this is kind of the standard. So in 64, let's talk about 128-bit keys. So in 128-bit keys, 104 bits are used as the password, actual password, and 24-bit initialization vector is there. So this IV is used to randomize the password. Well, let's talk about that later. So when a computer tries to access, connect to access point in web, usually a computer would send auth request, which is authentication request, to the access point. And then in this authentication request there won't be any credential, so it's safe there. But access point would send a challenge to the machine, and in response the machine will encrypt the challenge with the key that he knows and send it back to the access point. So he can access point can simply verify whether the machine actually knows the key or not and send a success message back. So let's talk about the web internals a little. I won't go into detail. So usually the web encryption happens with RC4 algorithm, and there's a CRC32 based checksum, so which is called ICV. So encryption happens by simply this RC4 is a stream cipher, so it's going to encrypt each bit by bit. So RC4 will use the initialization vector as well as the key to generate a ciphertext, generate a cipher stream, and then append that, XOR that with the actual message, actual content, along with CRC32 checksum of the message. Finally, it gets the message, and decryption happens by using same method. So it's XORing the message with RC4 cipher, which both parties know. So the idea behind these web attacks is that if you encrypt a message, or if you encrypt two messages with the same key, let's say you are encrypting A with this encryption key, and then you use same RC4 stream, so same combination of the web key as well as initialization vector to encrypt the second packet. And if an attacker could get both these encrypted packets, he can derive the XOR of A and B. So once this derivation is complete, it's possible to apply different statistical methods to derive the actual key. So we won't be going into that much of detail, but I'll be providing references that you can use. So in a web packet, there are two parts. One is encrypted and one is not encrypted. So encrypted part contains data and ICV. So data as well as the checksum is encrypted, but the 80211 headers as well as initialization vector goes in plain text. So this is kind of interesting. So IV is in plain text, and okay. So I'll provide more details on what are the different attack methods. Statistical method that can be used to derive key. So you can go through them later. So before moving into those details, let's simply go and do some practical attacks. So in terms of web attacks, we are going to use AirMonNG, AeroDumpNG, AirPlayNG, and AirCrackNG here. So you already know AirMonNG, we already have the card in monitor mode, and you already know AeroDumpNG. So let me simply run AeroDumpNG. This time I'm going to simply run it without any filters. Okay, let's wait for our networks to come up. Okay, so we have WhiteHat web network over here. It's in channel 8. BSS ID is this, so I'm going to copy this guy, and BSS ID is this, channel is 8. Sorry, 8. And this time there's a little difference. We are going to add. Sorry. So let's move into directory WhiteHat. So this time I'm going to add -w, write, or you can say -w, and I'm going to call this file dump web. So this additional parameter says dump all the packets that are captured into a file called dump.web. So now we have Tharindu connected in web network. And now we can see that there are some data packets flowing in. So the interesting packets that we have captured is in data section. So we need to get data section as high as possible in order to perform a effective attack. So in the presentation we talked about this IV. So in web we have 24-bit IV. So 24 bits is not enough to avoid collisions. Let's say we watch a YouTube video, maybe you can load a YouTube video or some kind of a video. Let's see how this value increases rapidly. You can see as Tharindu browses through, it's kind of increasing rapidly. Yeah. So if this reaches around 15,000, you can simply get the web password, or that would be enough. Maybe I can show you another attack. Let's say you are in a network that is not very active. So we can do something called packet replay. So we can craft a packet and send that to the network as if we are connected to it, in order to increase the IV count captured over here. So we have enough packets. Anyway, we'll try that. So in ARPlayNG, I am going to try ARP replay. So you know about ARP packets. Let me simply go through it. So I'm going to fake auth with the station before attempting the attack. So at the moment I am not connected. So in order to fake authenticate with the access point, you need to provide the MAC address of your card. So up to this. I'm not going to copy and paste any commands because it would make you feel like I'm keeping a secret. So I'm going to write all the things. Okay, so invalid reauthentication. Sorry. In order to run fake authentication, you need to provide the number of seconds you need to send a replay. So let's say 1000. No, let's say 5000. Sorry. Okay, so I am authenticated with the router, but this is not, I am not getting the password, I am just trying to fake authenticate with the router. So you will see my Wi-Fi adapter as a connected device as well. But any packet that I send is marked as lost because it's not identifying me as a valid connected device. So now I am going to run a replay with a replay, and I'm going to use the same parameters except I'll be using -b for the network. So now I'm waiting for someone to send a ARP request to the network. So normally in a typical network, ARP requests are sent very frequently. Just a minute. Did we make any mistake? Seems not. Okay. No such PSS ID in channel 8, but we have it. Maybe we made a mistake. Let's see. Yes. Sorry about that. This should be H. Okay, so I'm waiting for a packet. So I'm reading all the packets and I'm checking whether any ARP packet is there. Usually in a network you should get one pretty soon if someone connect and disconnect with it. Okay, so I just did a little cheat, don't mind me, so we can't really wait. So what I did was I ran ARP ping, so I am just sending a ARP request from Tharindu's machine to some other machine in the network. Typically it would happen in a network, so let's say you want to connect to 192.168.1 maybe 53, so if you are trying to connect to that, actually the machine should know the MAC address of your network card. So this resolution happens through ARP protocol, so the ARP protocol packets are kind of common. But in modern networks, so there's a thing called ARP cache, so every machine is going to cache the MAC address and IP address up to some level. So that's why our previous request didn't work, so I forcefully sent a request. Sorry. So over here you can see that we have reached around 80,000 packets, and over here you can see that AirCrackNG has cracked the web password, which is WhiteHat WWP. So this is kind of a little bit complex password. So it's pretty much easy to crack these kind of things in really little time. So in summary, we used AirMon to use monitor mode and detect networks. Then we used error dump to dump packets into a file, and then we used fake authentication to authenticate with the access point in kind of a fake manner, and then we used AR replay to replay our packets and increase the data count, and finally we used AirCrackNG to crack the password. So I'm just listing down these commands so that you can refer later on during your research or testing. So this is about the algorithms. So in AirCrackNG they use PTW method as well as FMS and FMS method. So there are different other attack methods. So let's say fragmentation attack, you can use it to derive password, but it's slow. So those kind of attacks are used to create create packets that look like genuine packets and perform injections. So the methods listed below are available in AR replay to use in replaying packets, and AirCrackNG use faster PTW method to crack passwords. So you can go through these references if you would like to know more details about algorithms and how they are actually working. It's kind of deep down to mathematics as well. So you can go through it later on. Okay, enough about web. So let's talk about WPA and WPA2, which is commonly used these days. So it's not easy like web, but let's see what is new with WPA and WPA2. Sorry. Okay, so in WPA and WPA2 we have key rotation. So in web the problem was there was kind of key rotation, but it was based on IV, which was just a few bits, 24-bit, which can repeat in long run. So in WPA, the entire key will be rotated for each packet. So it will be new 256-bit key per packet, and password size is longer. In web it was 13 characters and that was it. In WPA you can go from 8 to 63, so if you put a password with maybe 30 characters, it will be real tough. So there is a sequence counter. In web you could replay packets because there was no sequence. So if someone could capture a valid packet, he would replay it again and again to increase the data count. So over here we have something called sequence counter to avoid that. So you won't be able to easily replay a packet. And initial handshake, another handshake is required to get group keys, and it uses extensible authentication protocol as well as MIC, which is replacement of previous hashing mechanism, which is CRC32. So over here we have algorithm called Macro, which is 64-bit message integrity check. So with all these things combined, it's pretty tough to go for WPA and WPA2. So let's talk about what is difference between WPA and WPA2. WPA was actually a replacement to WEP. So in hardware level, it was necessary not to introduce any new changes. So even if it's a router that supported WEP, there should be a way to introduce WPA without any hardware level changes. So it's just software changes. So in order to accommodate that, WPA was introduced. In WPA, TKIP, temporal key integrity protocol, is used, and it still uses RC4 cipher. So RC4 was used not to introduce those hardware differences. However, with WPA2, we are using AES with CCMP. That is the main difference between WPA and WPA2. So instead of RC4, it's better to use AES. So when you have option, always go for WPA2. So let's proceed with other things. WPA2 has another 4-way handshake. It's a little complex. Let's not go very much into detail, so you can refer the image, as well as I have listed different URLs in each slide. I will be sharing this slide with you guys, and you can go through the links to learn more about the content in the particular slide. So the interesting part over here that we really need to focus is this. So let's say an access point and station is connected. Whenever these devices connect, access point is going to send access point nodes to station, and station is going to use this derive a PTK. So then station will send station's nonce, which is used to derive PTK in access point side. So this is used to generate group keys as well. So let's keep that aside, but let's see if we could capture a 4-way handshake, what would happen. So let's say we could capture a 4-way handshake happening in the network. In that case, we will know the MIC of that particular handshake. So if we could repeat, let's say a brute force, if we do this whole process using a password that is very simple, let's say 8 zeros, and if we could repeat that process again and again for all the password combination that we could think of, there should be a packet, there should be a handshake that has a similar MIC value in the brute force attempt. So if MIC values of your brute force attempt and this original packet matches, that is the password you are trying to crack. So this is the basic concept behind WPA2 handshake cracking. Okay, so I hope it's clear. Do you have any questions before I move into demo? Yeah.
What's the job of nonce? Does the nonce affect the handshake at all, or is it something totally different? Because otherwise, if the nonce keep changing, then the step for the handshake we still expect the same frame.
Yeah. So as you can see, the access point is going to send a nonce, and that nonce will be used to derive the PTK over here. So along with the station nonce, it is going to send MIC over here. So station nonce as well as access point nonce will be known to the access point. So it knows both nonces, which can be used to derive the PTK. I hope it's clear. Cool. Okay. So if I move on to WPA2 attacks, we are going to use the same attack toolkit. So we'll be using all other tools that we used in web attacks. In addition, we'll be talking about Hashcat and Crunch, but I just put them in light colors because we won't be going into demos of those, because this is not directly relevant to our area of interest, but we'll talk about it in the next session. So you know what is happening in each of these tools. In Hashcat, you can use GPU to perform different computations. So you can compute hashes using GPU. And in Crunch, you can generate word lists. So let's say you want a word list that contains all the numbers within range of 8 zeros and 9 zeros. You can simply give this Crunch the pattern that you want and generate all the combinations that can be there. So it takes time, but that's possible. So we'll move on with demonstration. So I will start the roadmap session once again. And you can see that WhiteHat WPA network is there. I'm going to stop this. Oh, looks like someone else is also using web. I'm going to get a huge bill. Okay, cool. So here WPA here. I'm going to copy this. And I'm going to change the SSID and give this WPA. So here I am listening to all the WPA requests going through, and let's ask Tharindu to connect to WPA network real quick so that we can capture handshake. I'm just connected, and you can see that it has captured a WPA handshake over here. So since we have the WPA handshake, we don't need this tool anymore. We can stop it, and I can stop this, and I can stop this. Okay. So in aircrack-ng, we can simply give the new packet file and the password list to crack it. But there are other options that we can use. So we can specifically say that we are trying to crack a WPA network. So it's better to do that. But there's no much difference if you give a word list. So I'm going to crack WPA. And sorry, I'm going to give a word list that it can use to try different combinations. So I have a one in this share. So there are a bunch of word lists in Kali Linux. You can use them in different purposes. So let's say you are trying to look through DNSs. You can use DNS map file and all that. But there's pretty interesting map. Let me just run this command and stop it, just so I can show you. This rockq file is kind of interesting. So it has several different passwords, I mean commonly used passwords, and different password acquired from maybe dumps and all that. So it's not just simply word list, but it has all crazy things. I'm not sure what is the origin of this. So you can use this to go through each line and try to derive the password. So I'm not going to use the full file because say it has this much of passwords in it, so it's going to take a while. So for now, let's do like this. There are two networks. Okay. So it's going to run through all the passwords in that file and try each and every one of them to derive the password. So it found the password secureadmin 284650. So let's imagine we ran this test against the original ROQ file. It might take days. I have tried it for about 5 hours without success because this was pretty much down. So cracking WPA is not an easy game, but there are ways that you can fasten up these scans. For example, you can create a file database, something similar to a rainbow table. In a rainbow table, you store already computed hashes in kind of a database. So you have the hash, you have the plain text in a database. So you compare whatever you have with the hashes and get the plain text of it. So the problem, there's a problem with WPA. I mean, there's a problem with deriving WPA keys using rainbow tables. Let me tell you why later on. But for now, let's try that. So I have sorry. Instead of this, I am going to say db, and I am going to say r. Okay, so that's the reason I got that selection screen, because I had two dump files here. So in aircraft-ng, I am going to say instead of W, I am going to say R, which is for databases that are created with aerolib-ng, which is used to create those kind of databases. So I am going to say give the database and pkf file. So it was instant. Actually, it tried 7,000 passwords. So compared to what we did before, and you can get the idea. So why is this not easy? Let's see. Okay, let's talk about that later. So I have the wrong title. Okay, I'll correct that later. So these are the commands that I use. We ran a dump-ng against the network and captured a handshake and used aircrack to derive the password. Then we used aerolib-based password database to derive the password as well. I skipped through this because you already saw it. So if you can't really get someone to connect to the network, then and there you can use deauthentication attack once again to deauthenticate someone who is in the network and make him reconnect so that you can capture a handshake. Okay, so in addition to this, you can look through hashcat document over here and crunch document which I have linked to get more details. So about why it is not easy to hack. Okay, I am going to skip through a slide. So before moving into the previous slide, I am going to go here. So why it is not really practically difficult to crack WPA and WPA2 networks? It's basically because cracking cost is increasing exponentially with the password complexity. So the complexity of password is secure URL. So keep the password complex. Let's talk about security concerns later on. Security ways you can secure from these attacks later on. So in addition, it's not possible to really have pre-computed permanent tables because the password sent over the handshake the password sent over the handshake contains SSID as the salt. So if you create a database of all the possible WPA passwords and keep it with you, you can't really go to some place and use that there directly, because you have to append SSID and then generate the hash in order to do this. So each SSID will be different unless you use something that comes default with the router. So we'll talk about that later. So you're pretty much safe if you use a randomized SSID and GPU. So we talk about hashcat. We can use GPU rigs or GPU combinations of GPU to crack these passwords pretty quickly. So in picture you can see a Bitcoin mining rig and also a mega big power, which is the largest big Bitcoin miner at the moment. So initially they started with 30 GPUs, then now you can see the size of it. So with this kind of computation power, actually these Bitcoins are based on anyway cryptography, so we are using same techniques over here. So with this kind of power you can derive keys faster, but I'm not saying you can crack a complex password within seconds or within days. So it takes time. I hope we are clear about WP and WPA2. We'll talk about security later. And what about WPS? This is kind of new in the game, so all the new routers has this WPS button built in, and it's kind of cool to press a button and get your device connected. So technique behind WPS is simply you can press a button in a router and then you can press button in your device. Maybe this guy has one. Yep, this guy has a WPS button you can press. If you press a button there and button over here, it will automatically connect. And sometimes they write the WPS pin in the back of the router. So maybe you have changed your password, maybe you have changed your default Wi-Fi password and all that, but if you still have the WPS pin written in the back, and if you have WPS enabled, you are pretty much messed up if router is not very secure. I mean, not protected against WPS attacks. So let's see that in practice. WPS is not at the moment covered with aircraft suite, so there are different tools. One is Wash. Wash is used to look for WPS enabled networks, and River is used to brute force different password combinations or the WPS keys, which are just numeric keys, and try to get the actual password. So let's go to this and so now I am looking for WPS enabled access points over here. I have multiple guys. I'm going to just zoom it out a little. Okay, so we have the WhiteHat WPS, which is actually that TP-Link router over there. So I'm going to stop the scan and this. In Reaper, you can give the interface, and the SSID, which is this. And now Reaper is going to use different combinations, WPS key combinations, to try and attack the network. So in order to do that, it should capture a beacon. Let's see. Okay. So it's trying different combinations, and you can see that it got a WhiteHat web password. So this is not as easy as it looks. Let me tell you why. Sometimes someone can come up and show you this kind of attack is really easy, but there are complexities with the new firmware versions and all that. So why it's practically different? New routers actually enforce usage counts. So if you fail, let's say in this TP-Link router, if you fail 3 attempts, it's going to lock itself for 1 minute. So every 3 attempts, you are going to be locked for a minute. So I try to run it through full range, and it will take around 6 days continuously to try all the combinations. But there are some routers that enforce even more security. So if WPS attack was tried out, it might block you for a few rounds, and it will decide to disable WPS itself until you go and enable it manually. So it's pretty tough. So if you have older firmware in your router, you can be vulnerable. So let's talk about security later on. So in security communities and media related to security, they strongly recommend disabling WPS. So most of the devices you can see around, maybe if they are concerned with security, they will disable WPS. Okay, so security concerns. I mean, how we can secure these networks. So securing WLAN, you can in your home network. So we are going to talk about this in two different slides. One is just WLAN. I should have mentioned securing personal WLAN here. So over here we are in personal WLAN. It is better to use WPA2 AES based AES CCMP based encryption always, and use personal standard. But if you can use enterprise, that's better. So disable WPS, keep it disabled, and some routers simply show you that WPS is disabled. But when you run wash or some other tool that detects WPS enabled routers, it will simply show that WPS is still enabled. So make sure you test your routers and see whether WPS is really disabled, even if it says disabled in the admin console. So use lengthy complex passwords. Don't use dictionary words because they can be in word list. So there are different attacks that, there can be attacks where someone uses dictionary words and combine random numbers and characters, let's say brute force, combined with the word list. So let's say you have a dictionary word and then you have added some numbers to make it secure. Even if you do that, it's easily possible to use that kind of attack that I mentioned before to crack the password. So use complex passwords, try to avoid dictionary words, and of course use unique SSIDs. I don't have to say here, so you guys already know. WPA is using SSID in combination with password to create the four-way handshake. So if you use SSID that comes with your router, so I have TP-Link here, maybe it's a T, they have the company name as the router name. So if you use that, if you keep that same thing, someone can create a database of all the passwords for that given SSID. But it will take time, but it's possible to create such a list. Make sure router admin panel is protected with a different password, so don't put the same credentials for the Wi-Fi network as well as for the router admin panel. So keep it different in case someone get in, they can't really get into the admin panel. And use guest accounts. Maybe you can, maybe someone will come to your home and maybe you know the guy and you enter your password in his phone and all that. But the problem is that your password is stored there. So don't simply do that. Create guest accounts. All these new routers has guest account features enabled. And I mentioned this before, avoid dictionary words and passwords. So about enterprise wireless networks, use WPA2 AES ECMP enterprise mode. Other rules apply. Disable WPS. Normally these routers will not come in WPS in enterprise if you use enterprise devices. But anyway, if you don't, keep WPS disabled, and in enterprise mode you need to connect with radio server for authentication. So your user credentials will not be stored in the router, so no one can simply come in and get them easily because they are stored in a different server. So in enterprise mode, we use per user sessions and per session random keys. So each user connected to a enterprise WPA2 network will have a different certificate or different random key for the session. And it's possible to use MAC validation. Actually, it's possible to spoof MAC addresses, but still it's better to use MAC validation as well. Okay, so looking into future, so there was an interesting project called the Cloud Cracker, which gives you access to 604 million word list for $17 and 1.2 billion word list for $34. So you can simply send them a handshake and let them crack it for these price tags. This is down at the moment, it's dead, but there can be situations where GPU based cracking comes in as a software as a service. So it's a possibility. And then there's this hot topic, which is AES having a backdoor. So there are different discussions about this. Go through the link over here. It's not, there's no identification that it's backdoor, but maybe. Okay, so it's kind of my last demonstration. Avoid untrusted wireless networks, and why is that? So let me show you a device, pretty interesting device. So this little guy is access point, and it has OpenWrt in it. So you can pretty much do anything. I mean, it has Linux kernel running, so you can install different packages. Maybe if you want to install, like the tool we used, ARPing, you can simply use the package manager built in and install it. And if you want TCP dump, maybe you dump the network traffic going on, you can use that. Let's see that in action. So this guy is about $35, and there are other routers. So commercially available routers that can be flashed with OpenWrt. So even if you don't have this kind of a guy, maybe look up in OpenWrt. Maybe they will find. Maybe they have listed your router as a supported one, so that you can download the firmware and simply flash it to your device. Sometimes they need hardware hacks, but it works. So I don't have it powered on. Let me quickly go through. Okay, so at the moment it's programmed to connect to this router. So it's actually relaying a network, relaying our WPA network as a free Wi-Fi access point. So in a real life situation, maybe you will find a free Wi-Fi hotspot that is relaying some other network and doing some additional things on top of that. So let's wait for it to come up. Okay. Okay. So this is the admin panel, normally the GUI. So this is the GLINet admin panel where you can define different settings very easily. But there is a mode called advanced settings which is going to load OpenWrt itself, OpenWrt UI. So this is OpenWrt UI, I mean web panel. So you have the overview of device, and actually I showed you different networks over the demo. So I could have simply created all these networks using only this device. Oh, looks like there are a lot of users here. Okay, if I wanted to create different networks, I could simply add different networks over here, and I can even create interfaces. So in a typical router, you can have one interface, and this black guy has around 4 interfaces that can be assigned to different networks. But this one can have any number of interfaces depending on your need, but it can't really handle a big traffic because it's just a small device. Maybe you can plug in a fan or do some kind of hardware modification to get it handle high load. So at this stage, what we are interested is that we have a lot of users here. I'm going to simply SSH into the router. So you have a Linux shell, can do anything. Actually, I have SSL script here, which we will talk in a different session. I will tell about it later. So we have pretty much all the Linux command. Maybe if you don't have anything, you can install it as usual. So over here, I am going to simply run TCP dump. Oh. Okay, so I can see all the traffic flowing between devices connected to this access point over here. Let me run a different flavor. Just give me a second. Okay, so I have dumps of all the packets that are flowing. And if I access something like Google, you can actually see the traffic flowing between you and Google in terms of HTTP headers and all that. So you can further, clear this out and remove unwanted traffic. But for now, let's stop there. I will share the presentation. You can have the longer command which I was trying to copy and paste over here. Okay, so demos are pretty much that. So you can see that, oh yeah, there's an interesting one here. So over here you can see that it was sending a packet with all the content, and there was 404 message for someone over here. Okay, so sorry about shifting between machines. Technical difficulties tend to happen. Give me a minute before I move on to the slides. Okay, so that's it. And what more to expect from White Hat about wireless security? As I told you before, wireless is not just limited to Wi-Fi. So we are going to talk about Bluetooth security, maybe in a different session. So I have this little guy here, which is a development board for Bluetooth 4, and this guy can transmit Bluetooth 4 packets as well as receive them and read them. Maybe if some device is communicating with a phone in an encrypted or unsecure manner, we can simply listen to what it's saying, what it's communicating, maybe the wristband. It might be communicating with the device unencrypted. So we can look into those things. Bluetooth is anyway gaining popularity now with Bluetooth low energy profile. And of course, we have ultra portable wireless security recipes with ESP8266. ESP8266 is a very small Wi-Fi module that can be used with projects like okay, so I was in this slide. So ESP8266 is a very little module like this. I have everything actually here, so it's little messy at prototyping stage at the moment. So it has this module which is listening to all the Wi-Fi networks. It can capture packets. It can move to monitor mode and monitor different activities happening. And of course, we can plug in a display, use I2C devices with it. So I have a GPS module, display, and I'm planning to plug a few other things in so that we can have a portable wireless security auditing station. Maybe we can talk about that later on. And one more interesting thing. So in terms of RF, so we have a large range of radio spectrum. So there are ways that you can inspect this radio spectrum using computers. So it's pretty much known as software-defined radio. there are tools like GNU radio that you can use with these devices that can listen to radio frequencies. So, for example, HackRF1, which is pretty famous and it's costly. But there are other devices like this little guy, which is in this image. I'm not going to remove it now. So this is widely available and kind of cheap. So you can use those kind of devices to listen into radio spectrum. So I am looking at Wi-Fi at the moment. So here around 2.4 gigahertz we have Wi-Fi. So we can see what's going on. And if I move to like 343, this is 433. So you have, I am sure you have seen these things. So car keys, you can see what is the code that it is sending out in RF. So usually you can use these signals, decode them in some ways, maybe with the GNU radio and all that, and get actual bit pattern that it is sending out. So if that is not maybe encrypted, or if that is not rolling code mechanism, you might be able to simply copy the code that it is sending and repeat that to do whatever you want with it. So these kind of things we are going to cover, we will be able to talk in future sessions. Okay, so that's it. With great power comes great responsibility. So use these with caution, be within legal limits, and only test your own devices with proper authorization. So that's it. Thank you guys.
Thanks a lot, Ayoma. So we won't take much time. Next session will take around 10 minutes. So sorry for taking so long to complete the session. So just to mention that Ayoma is sitting next to me at the workspace. So every day we see some delivery coming from eBay with all kind of these devices. So, okay, so you can. So next session is some thing about news, what's going on, what's about to come related to security. So Milind is another member of the platform security team of WSO2. Previously he worked at Sri Lanka CERT. He's coming with the background of Pentesting, and also he'll continue the next session. So we'll wind up everything in like 50 minutes. So please bear with us. Thanks.
Thank you very much, Tharindu. So I'm not going to make it long, obviously not long, and this is not general news like what we see in any hacker forum or something. What we want to do is from this session we would like to give you an idea of what how you can contribute to the community, and aggregate what is not aggregated at the moment. Like you can see all the news going on in Facebook, Twitter, and all sorts of platforms, but we are trying to bring in something what is not already in. So I would like to share two upcoming new events. The Black Hat USA. This time it's happening in Las Vegas. So in 30th they'll be starting, and I want to point out two interesting topics which we will be covering on as hands-on sessions. These are like $3,000 sessions. So obviously, hopefully if someone can join, good luck. Advanced piracy will be about covering up tracks and stuff. So, and application Android application hacking. So that's mainly reverse engineering. And another interesting conference, LASCON. This is a OWASP conference which is coming on November. Right now you can submit papers. They are calling for papers in this link, and last year they used to have this mobile wearables, so something coming up new in IoT, and some other stuff with API security also. So in case if you missed, because this AppSec Europe is already finished, but I thought it's worth sharing with you, and the session videos are also already out, and the slides as well, and just a little bit of a story. So how the cat got out. So I think I hope everyone knows the movie. So in this, a guy tries to impersonate as another pilot and several other people to evade the authorities. So I don't like to use the word good guys, I just say authorities. So Adam Bowling. So I hope you all know who he is. He has the most visited illegal file sharing website. So he is the owner of Kick-Ass. So he goes busted a couple of days back. So how he got busted, I would like to share with you. So here, obviously, he wanted to get some publicity for his file sharing website. So he go ahead and made a Facebook fan page, and that's the first mistake he did. So after some time, maybe because to find out the legitimate Facebook fan page for Facebook might have taken some time. So FBI went with a warrant to Facebook, and obviously Facebook happily gave out the information because they had a warrant. So that turned out to be an Apple ID. So obviously, then they went to. Then the FBI went to Apple with another warrant, and they also happily gave out the information. So, and it turned out to be that the guy had the Apple ID called trim@me.com, and that was getting admin alerts from Kick-Ass from various servers set up in several countries, plus one in US. So, and with that, and another blunder he had made was like he had used this Apple ID to do a purchase in iTunes, and his IP address is already there. So that was also given happily, and that is how he got busted. So there's a brief information. So I would say tactics without strategy is noise before defeat. So it comes from art of war. So if anyone of you like to go ahead with anything, like as he said, be responsible, but you have to have your strategy, otherwise your tactics will be busted. Thank you.
Thanks, Melinda. So in this news session, like we plan, like if you are already working on projects and all, you can share the information with us, so we can announce the community that you're already working on this, so others also can get some feedback, like they can provide feedback for you. So we'll wind up the session, so feel free to get the refreshment if you didn't get it yet. So, and we have to apologize for you, like for not being able to accommodate you comfortably. So there were nearly 300 RSVPs when we checked today. So, but we didn't expect all of you to show up. So that happens, right? So anyway, so we hope you would join us in future sessions as well. So if you would like to come here and speak, do a future session, so please talk to us and share the feedback in the meetup.com event and in Facebook page, so how we can improve, because this is the first time that we are doing it. So we are just like you, some individuals gathering together and trying to do something for the community. So we hope like we could share some knowledge with you today, like what I felt was when I was doing the session, like it was not the basic level, so we had to assume that you already know some stuff, otherwise we couldn't have managed the time, like we can't go with the very basics. But so we have the recording, we will share it with you, so you can watch it and try out all the steps, and you can contact us. So that's it. Thanks all. And also, like behind the scene, like I have to thank all the members of the WS2 platform security team, Dulanja, the team lead, and Milinda, Ayoma, Prakash, and also WSO2 for providing us all the facilities, refreshments, and HackerCG for advertising, especially Siva, and also some members in our like Kapila, Danisha for helping us to organize this stuff. So thanks all for coming. So we hope you would enjoy this session. So we hope you would show up in our next sessions as well. Thank you very much.